All right, so now that we have looked at how the eye normally works to accommodate things that are closer, what if you had a problem with looking at things that are closer? They just seem blurry. It means that this particular function is not working, and no matter how much you squint, things will keep on falling at the back of the retina, so to speak. But these kinds of people don't have a problem with actually looking at things that are far. So this type of pathology is known as hyperopia or farsightedness. So in farsightedness, uh, you can you have the ability, okay, not the ability, but you have no problem in seeing things that are far, okay, because they will fall onto the retina. But when it comes to things that are closer, especially than 60 meters, no matter how much you squint, no matter what you do in order to accommodate what is near, you can't see them. So you have um, uh, seeing things that are near they become blurry, and you can't see. So try to think of a person who's okay with seeing things that are far, but once it comes to seeing things that are closer, especially things like reading, they can't do that. All right. So what happens mostly in these people is that they have an anatomical feature of short eyeballs. Okay. So because the eyeball is short, you find that even though the lens is okay, it's going to focus on where the retina should have been, but because it is short, it passes the retina place and goes behind the retina, so to speak. And so you find that in these individuals, there's this prolonged effort to accommodate, and they usually have headaches, and they try to squint, and most of the time they'll actually have a cross-eyed uh, arrangement, especially if it's in children. But how do you correct this? If you put an external convex lens which will bend the light just before it hits the cornea, this might help with the bending. Then the internal structures don't have to bend as much. Then everything can fall on the retina because you'd have shortened the focal distance. So this is hyperopia or farsightedness. Okay, so the next component is accommodation of farsight. So what happens when things are far and you want to bring them into uh, perspective? So farsight is accommodated when there is tension increase in the zonule fibers. So the only thing that has to happen is for you to pull the lens. Okay, so when there's that tension, uh, the lens is pulled, and once the convex lens is pulled, it will not allow for much refraction to occur, and so the focal distance will increase, and therefore you'll be able to bring everything to the retina. Um, if normally what happens is, if this doesn't occur, then things fall before the image will fall before the retina. So you will need to uh, reduce the bending, and this can only be reduced if you um, reduce the curvature of the lens. So once the curvature of the lens is reduced, then everything will fall on the retina. So how do you do this? The ciliary muscles have to relax, you see. So once they relax, this side is relaxed and the other side is relaxed, it pulls on, okay? It pulls on the lens, and that way you will reduce the curvature. So what about people who can't see far? All right. So when you can't see far, that you have no problem seeing near, that is called nearsightedness, myopia. All right. So this can occur when the eyeball is too long, or it is intensified when you are reading in dim light, or children sleeping in lit rooms, or studying or looking at the computer, so on and so forth. All of these can cause this inability to look at things that are far. So what happens is, in myopia, it is as though there was no accommodation of things that are far. So things fall before the retina, no matter how much you tried to straighten the zonules and pull on the lens, everything will fall before the retina. So what will happen is you need to try to diverge some of these lens rays before they get into the eye. So use a concave lens, and then it will diverge, okay, and then once it hits the cornea, then it will be able to be placed on the right spot, because you would have exaggerated them a little bit before they enter. The last bit is astigmatism, which is really just the curvature of the cornea not being uniform. And in these cases, you have light rays refracted to a different focus, and things are just blurry, whether far or near, and they're corrected with this cylindrical lens that is placed in such a way that you're going to equalize the refraction or the bending at all median points, and at all meridians, and that way you'll be able to focus the image to the proper place. So basically, this is what we are going to talk about today. So go through this, and the next time we meet, before we get on to the next part, we're going to have a quiz.